Number 21 is a real tricky question. They're basically asking, they don't even ask you to solve, they just ask you which one is the right one. For example, which one could not be used. The reason why it's choice number 4 is because it looks like they multiply the entire bottom row by 4. They got negative 8x, they got plus 8y, but this should have been negative 32. Should have been negative 32, but it wasn't. Even in this case, in choice number 4, they multiplied the entire top one by 2. They got 8x plus 4y equals 44. That's correct, but this part is incorrect. This should be negative 32. In number 22, they're asking you which function is a minimum that is less than the one shown. Well, this vertex of this parabola is 3, negative 7, therefore the minimum is negative 7. Which function has a minimum that is less than the one shown in the graph? I put all these in my calculator and I came up with choice 3. I put in x squared minus 2x minus 10. If I go to my table, notice the lowest value is negative 11. That minimum, it's like way down here. The parabola would look something like that. That minimum is definitely less than that one. And number 23, they're asking you which of these statements describes a situation for an equal difference over an equal interval. Basically, you're looking for linear growth. In option number 1, I took 28. Well, I thought I read that as 28. It was the initial amount. Well, whatever. Let's just pretend that 28 centimeters was the initial amount. I just add 3.5 per day, and this is what I get. It's going up by the same amount. It's definitely number 1. For number 2, I did y equals 1,000 and 1 minus 0.15 to the x, because that's my exponential decay formula for a problem like that. And if you notice, this is going down by 150, this is going down by 122 or 127 and a half, blah, blah, blah. It's going down by different amounts. It's definitely not number 2. In a culture, say you had 1 bacteria and it tripled, now you have 3, 9, 27. These are all going up. This is going up by 2, this is going up by 6, this is going up by 18. Okay, so it's not that one. Choice 1 only. Now, talking about residual values for a scatter plot. Residuals are the distance from a scatter plot point to the line of best fit. So imagine you had, a scatter plot, and then you had a line of best fit. If this is your scatter plot, this distance would be the residual. This distance is the residual. This distance is a residual. This will be a negative residual, positive residual, positive residual, negative residual. Okay, so what you're looking for is a residual graph that models a great line of best fit, does not have any shapes or patterns. See how this looks like a parabola? That's not going to be it. This looks like a parabola. That's not going to be it. This kind of goes up and down. That's not going to be it. What you're looking for is tightly clustered points around the x-axis, which is like number 3.